Okay, the rest of the section is going to be applications with quadratics. So this first one goes, the length of a rectangle is 5 inches longer than its width. If the area is 66 inches, what are the dimensions of the rectangle? So I'm going to let the width be x, and then the length is 5 inches longer than the width. So that would be however long the width is plus 5. And then the other piece of information we know is the area, and that is 66 inches squared. So what are the dimensions? So remember for a rectangle, this would be like our x, this is our x plus 5, and then we go length times width, and that equals area. So area equals length times width, or width times length, which is the order I'm going to write it in, just because it'll look nicer. So 66 equals the width times the length, and then that gets us to something quadratic that we can solve. So let's run the x through. So that gives us 66 equals x squared plus 5x. Remember, when we have a quadratic, we want to get to 0, so we're going to bring the 66 over. 0 equals x squared plus 5x, and now minus 66. Looks like it's going to factor. So two numbers that multiply would be 66, negative 66, and then our 5 apart would be a positive 11 and a negative 6. So negative 11 does not make sense as a distance. So it looks like x is going to be 6, and then 6 plus 5, that would make the other one 11. So this one is 6, and then the length is 11. And the reason we get those two solutions is because if this was negative 6 times negative 11, right, that would also end up working out. It just doesn't make sense in terms of the application. Okay, number 3 goes, the width of a rectangle is 5 less than twice its length. The area is 195 centimeters squared. What is the length of the diagonal this time instead of the one of the sides? So let me get a little picture going up here. This is asking for the diagonals. I'm going to call that D. And length, the width is blah, blah, blah in terms of the length. So that's going to I want length to be X. And then I want to write width in terms of it. So I'm going to let length be X. And then the width is, that's like equals 5 less than twice the length. So 2x and then 5 less than that. So this side's x and this side's 2x minus 5. And it doesn't mean that this side's long and this side's short. This is just how they described it to us. We're looking for the diagonal, but to find that diagonal, I would need the length of each of these sides. And to get these sides, what they gave me was area. So that tells me I'm going to go back to area equals length times width again. Use that to figure out what these x's are, so that gets me the lengths, and then I can do Pythagorean Theorem to get at the diagonal. So this is going to go x and then 2x minus 5 equals 195. And then I'll FOIL, bring the 195 over, and distribute and bring the 195 over. So 2x squared minus 5x minus 195, that makes 0. Can't factor anything out in terms of a common factor. This does not look like it's going to turn out to be nice numbers, so I would just go straight to the quadratic formula, which is what I did. So we'll have 5, negative 5 is 5, plus or minus 5 squared minus 4 times a times c, all over 2a, so 2 times 2, and then I kind of tossed all that in the calculator, and this came out to 5 plus or minus root 1585 over 4. This negative root isn't going to make sense, same as the last example, that we're just getting a positive and a negative version. That's the positive one we want. So if you do 5 plus square root of 1585, enter, divided by 4, enter in the calculator, I got x to equal 11.203 with more decimals. and it's telling me to give my answer to 2 decimal places. So I kind of went with, I think I mostly calculated with 3 and then rounded, and that kept it within where I was going to match to the second decimal. So once we know that, then that is our length. So then our width, that is going to be 2 times that value minus 5. So that came out to 17.406. Okay, so then here we got the width as 17.406, length is 11.203. And again, it doesn't matter which one we label short and long, they will come out as they do. And then remember we have Pythagorean Theorem that says a squared plus b squared equals c squared. So this is our a and our b, and what we're looking for is c, which in this case I labeled d for the diagonal. So we'll do 17.406 squared plus 11.203 squared, and that's going to equal d. And then I'll throw the root over this side, and then that undoes the square on this side. And after that, I just chunked all that with the calculator, and I got 428 with some stuff. And then the square root of that, d came out to 20.70 to 2 decimals. Okay, so this one goes, a gardener has 840 feet of fencing to fence a rectangular garden. One side of the garden is bordered by a river, and so it does not need any fencing. What dimensions would guarantee that the garden has the greatest possible area? Okay, so if we're maximizing something, and it's in the land of quadratics and it involves an area, that sounds like it's going to turn into an upside down parabola, and what we're going to find is there's going to be some length of fencing here that is going to maximize area. So this sounds like a vertex problem. Anytime we're looking for mins and maxes, that's going to be kind of a turning point situation. So we got to figure out, we know he has a total of 840 feet of fencing, and we're trying to fence these 2 lengths that are the same, and then this third length that's different. So let's call the 2 that are the same, let's call those x. So then that means I would have 840 feet of fencing minus these 2 sides is what I have left over for this. So this would be 840 minus 2x, and that would represent that piece right there. So now to try to figure out the area is going to be length times width again. So that's going to be area is x times 840 minus 2x. So then distributing, area will equal 840x minus 2x squared. And then the area is going to be at a maximum, like I said, when we're at the vertex. So if this was all width, say, and no length, the area would be 0, and if it's all length and no width, the area would be 0. That's these 2 places, and in between there, you can kind of guess it's going to be square. That's the spot where we're going to maximize area. So to find the vertex, in this case, I think the easiest way is x equals negative b over 2a, and that's going to give us the x coordinate that we would need to maximize. So let's see, this would be x equals negative b over 2a would be negative 840 over 2 times negative 2. So that's double negative, so positive, and 210. So 210 feet would be this side. And then if you do 840 minus 210, that's going to give you 420 feet for this side. And so we're kind of getting these 2 squares. And then I think somewhere it also asks you what would be the maximum area. And so in that case, you would just say area equals 210 times 420, and I got 88,220 square feet for the area. Okay, and then the last one, the height of an object tossed upward with an initial velocity of 112 feet per second is given by the formula, this thing, where h is the height in feet and t is the time in seconds. So first is find the time required for the object to return to its point of departure. And so what that means is if it's returning to its point of departure, then its height would be 0 again. So, and we know that because when t is 0, h is 0, right? So what we're solving is negative 116t squared plus 112t. And I would factor a negative 16 out of there. Actually, I'm going to write the 0 on the other side just because it looks better to me. And that's going to leave a t, and then that will flip that sign to a minus 7 equals 0. And so then here we have negative 16t equals 0. So t equals 0. That makes sense. At t equals 0, it's leaving the ground. And then here at t equals 7, that's when it would be returning back to the ground. And then what is the maximum height of the ball? So maximum height, anytime again we're maximizing, that's going to be a vertex. So we could do the vertex, the time, because this is height and this is time. So the easy way is it's going to be halfway between these two intercepts, right? So it's going to be at 3.5. If you want to confirm that, you can do t equals negative b over 2a, so negative 112 over 2 times negative 16. And jump that in a calculator and you will get 3.5, which makes sense because it would be halfway between when it left and when it landed. And then to get the maximum height, you just toss it back in here and solve for h. So h is going to be negative 16, 3.5 squared, plus 112, 3.5, and I got 196 feet.